well, probably a professional RC modeler or most experienced, probably Brian Buas is going to talk to us, and he, well, you know what? I'm gonna mute myself and I'll let him talk. And if you need to share the screen, Brian, you can share the screen, or you can just talk through it.
I think we're good. I may have to do some quick drawing here and there, but we'll figure it out when we need it. So hi everybody. Anybody who doesn't know me, I am a new convert to building scale boats, but I've run just about everything there is in a model boat otherwise to run. I have raced borrowed scales in the past. Won the 2012 FE8 scale nationals. So it's going to be fun building some new boats. But you know, everybody loves the big pretty boats. You know, the showgirls, as some people call them, at the big multi-class races. And you know, my whole point of the talk today was let's look at the underbelly of these things that we all like so much, and see if we can't help people figure out some more performance and explain some of the things that make a difference on performance. And we'll start with a quote from Brad Lewis after I prepped his first boat. And he went out and picked it up and set it in his lap. And we ended up patching up 3 different cuts on him after that. And he said, does everything have to be that sharp? And the correct answer to that is absolutely. If you can't cut yourself on it, it's not sharp enough. And I don't care if it's turn fins, rudders, props, sponson edges, all of it. And it's one of those attention to detail things that makes a huge difference in how things perform in the long run. So we'll start with turn fins. And we've probably all run boats and had issues where you'd have a boat that no matter what you would do would pull into the course, whether we're turning right or left, depending, you know, doesn't matter on what class boat you're playing with. It always has a habit of pulling into the course no matter what you do with your rudder trim. And more often than not, the culprit to that is either a poorly aligned turn fin or a turn fin that hasn't been sharpened properly. And I've seen a lot of boats that the leading edge of the turn fin is sharp on one side. You know, it's got a sharp edge, but it's a rounded section on the leading edge of the fin. And what that rounded area does with the fin is it keeps the water attached to the outside of the turn fin and causes it to pull into, you know, pull the boat that direction. It's essentially half of a complete airfoil, causing lift because of that curve. David, you may want to give me the screen for a second here. And I can throw up a picture of what I'm talking about. Roughly.
I stopped sharing, and you do have share screen if you want to share it, or I'll pin you as talker if you'd like that instead. Did you want to share your screen at all, or did you want to? Okay, you're good.
Yeah, we're good. So on the left of the screen is what you see for a sharpen. You know, a lot of people sharpen a turn fin, and a lot of it's just an accident of the way you sharpen things. You know, you round edges if you're doing it by hand, and that section will cause some lift on the turn fin and pull you into the course. The right hand side of the screen with that chiseled edge, people think that chisel, even if it isn't a real deep chisel, is a lot of drag, and it's not. What you're doing is separating the water off the blade at that point and aerating down the edge of the turn fin, and it cuts down on that lift caused and doesn't pull the boat into the course as much. If you really want to get exotic, you see things like you see on the big boats, is you'll see that chiseled edge and then a cut back which will really remove water from being attached on the outside of the fin, and aerates and frees up the fin. Less drag all the way around, no pull into the course. So one place to play with. Other reasons for handling, turn fin issues with handling are, tuck or lift because of the angle of attack on it, and also checking to make sure that the fin is aligned with the riding direction of the boat. I mean, you'd be surprised how many, even production fiberglass hulls, you measure the back of those sponson transoms and they're not perpendicular to the center, or perpendicular to the center line of the boat. You always end up having to tune those turn fin brackets to really get things straight and measure them carefully. So that's about it for a quick turn fin lesson. We get to rudders, and again, it's let me run back to turn fins real quick, just for a quick thing. The trailing edge on any of these parts, whether it be turn fins, rudders, propellers, how sharp that edge is at the trailing edge is as important as how sharp the leading edge is. It's a function of how well water clears off the contact surface. If you've got a rounded corner at the back of the turn fin, or at the back of a prop, or the back of a rudder, the capillary action of the water draws water around the back and tries to reconnect it, and it causes a huge amount of drag. In the straight line boats, we found it was good for 2-3 miles an hour. And when you're playing with 130, 140 mile an hour boats and you're at that bleeding edge, it's a big chunk. Just making sure everything's really, really sharp. So rudder shape wise, you pretty much want to go to a pure wedge on anything. I don't think anybody uses anything else nowadays. There's not a whole lot of sheet metal rudders out on the market anymore. But it's the same type of thing on the leading edge. If you pop a rudder out of a package and look at it closely, most of the machined rudders have a little flat leading edge on them, just because that's as good as it's going to get coming off of a CNC machine. Any of the Accutech or Speedmaster rudders, their wedges, when you pop them out of the box, you end up with, that's an exaggerated cross section, but you end up a little blunt leading edge on it. And what that ends up doing to you is it gives you a very wide dead band around neutral. So you end up with it creating a bubble coming off the leading edge of the rudder, and you don't have as effective a rudder when you need it to turn the boat. So it's just a real simple fix on those. And again, I'm going to give you an exaggerated picture, but you just sit there and file, a very straight edge pyramid, chisel edge on the leading edge of that rudder, and it will cut down about, it'll cut about half of the throw required to initiate a turn out of the rudder throw. It'll make your rudder much more responsive, and it will tend to have them stick in the corners better than you expect them to a lot of times. As far as propellers go, as I was saying, it's you want those things sharp. I know we all have our favorite propellers that we've been running for years on a particular boat, but sadly, you sort of have to bite into the reality that propellers are consumables. You're going to hit things, you're going to bend things, and it's really hard to bend them back to where they were afterwards. There are some techniques to get there, but you oftentimes you're better off just going back to a fresh blank and reworking it. But that trailing edge, again, I dealt with this question on forum a couple weeks ago, and it was all the prop gurus. It was Andy Brown and a bunch of the others, and it was a debate on what angle to cut the trailing edge to on a given blade. And I don't know what everybody's running for propellers at this point. I mostly deal with the ABC stuff, and the way they're cast, their trailing edge is cast at about 70 degrees, and it's not a function of performance, it's a function of being able to get them out of the wax molds and being able to produce them. So when I work on one of those blades, I'll cut that trailing edge so that the trailing edge angle to the pressure face of the blade is 90 degrees. And again, that allows you to really sharpen up that pressure exit, and you don't have water wrapping around the trailing edge, which seems like at the speed our propellers are traveling that you wouldn't have an issue with water wrapping around the trailing edge, but it's shocking amount of drag and load by not having that edge really sharp. I run speed controls in my electrics that all have data logging, and I've done some tests, and you can increase your current draw with an improperly prepared prop, identical castings, by more than 10%. So that whole sharpening and maintaining sharp edges on the propellers makes a huge deal. I mean, an ideal cross section for the propellers that we run is a curved wedge with very sharp, it's that. If you cut a prop down the middle, that's what you want to see. And keeping those edges sharp on the trailing edge truly is as important as getting that leading edge sharp. And if you want, so a trick for guys who don't want to have props be quite as disposable, want to leave a little more thickness in the blade, you can do the same treatment to the leading edge. You leave the leading edge 5 thousandths thick before you really go after it and sharpen it. You can put a chisel edge on that and maintain the thickness a little further forward into the blade and not give up a ton of performance. Let's see, what else for you? Oh, the other part that nobody thinks about. Well, I shouldn't say nobody thinks about it, but that sharpness applies to the sponsons. Trailing edge of a sponson should be 90 degrees from its ride surface, and if you're not careful and you've had your hands in water all day, you should be able to cut yourself on it. Same goes for the tunnel wall surfaces, the outer edges of the sponsons. Everything needs to be sharp. It truly improves the way the boat handles, and it just stops being sticky over time. That's about the basis of what I can give you for a quick overview of what we're playing with. I'm happy to answer any questions. David, you can unmute people.
That would probably help if they could unmute themselves, right? All right. So you're unmuted, or you're able to be unmuted and ask Brian some questions. I know I've got questions. I hope that you do too, and we've got some time to answer them. So ask away.
Snowman, I have a question.
Okay.
What about the difference between a straight turn fin and a curved turn fin? On the full size hydros, you only see straight turn fins, and on our model hydros, so often we're using a curved turn fin, which would seem to cause totally different dynamics.
It is very different dynamics, and I can't say for sure on the full-size boats. I would argue that the big plate turn fin that they use and the brackets they use are a lot of structure, and I hate to say it, probably a little bit of budget constraint. I mean, if you wanted to, you could certainly build a curved turn fin big enough to run on a full-size boat, but you would have to mill that you'd either have to bend it like we do with the model turn fins, which is putting a weak point in. I mean, it's a break here point for a big boat with a lot of load on it, or you mill that thing out of a piece of billet, which is going to be obscenely expensive. Yeah. But as far as the reasoning for the bent turn fins, and in some class, I know you know, our 10th scales, we can't put a bend below the water line on the turn fin. I still run a turn fin that has a bend above the water line, for the simple reason that you can take a vertically mounted turn fin bracket, so you know, perpendicular to the water and right attitude of the boat. If you put a bend above the water line on that turn fin, when you cant it front to back, you can actually change the lift characteristics on the boat. You know, if you cant the thing back, it's drawing down on the inside sponson. If you cant it forward, it's going to float the inside sponson a little bit. And it's a way of fine tuning ride attitude in the corners.
Okay. Yeah. Yep. Yep. Seen it. Thank you.
Mm-hmm.
I've got a question. This will seem a little odd of a question, but this is more, my friend was thinking about it. He's building himself a new tunnel boat right now, and he actually had the idea of trying a turn fin on a tunnel boat, which to me doesn't sound right, but I'd like to hear your thoughts on it.
The earlier tunnel boat designs often ran a small turn fin. The old Dumas designs, the old Prather Lapcats, they were fairly flat sponsons, not a lot of dihedral. Most of the modern designs have gone to a very high dihedral angle and aerodynamics to make them turn without having a turn fin.
Yeah.
If he's designing a modern style boat, yeah, there's no need for it.
Okay, thank you.
Mm-hmm.
I would like to point out, Brian, Eddie K, he made a good point that in the Unlimited class, back in, I don't remember the rear right, but he has a 2006, there was a team that did have a slightly curved turn fin. Wasn't the same to our effect that we have, but it did work well. They won the Gold Cup, and shortly after that, it was outlawed in the Unlimiteds.
Well, that's why they're not using them now. That's a pretty simple answer to why they're not running a curved turn fin. They got outlawed. More questions? What can I help with?
All right. Can you hear me?
Yep, I got you.
All right, excellent. So I got this 7-foot Circus roughly, and I have a lot of people telling me, you know, it's meant to be for a turbine engine, but recently I'm turning into a brushless. But seeing you're talking about the turn fin, I got this turn fin, and I don't know if it's, so you're talking about on this size of a boat, should I go for more of a curve or should I go for more of a straight angle?
Well, the real question is what is the intended purpose of the boat? If you're going to maximize performance, if you're serious about getting as much out of it as you can, especially in the corners, you're going to do some variant of a curved turn fin. Scale appearance wise, the curved fins don't look like the real boats. I admit that. I mean, my preference on a Thunderboat is actually a big modified double bend teardrop like I run on my outriggers. But again, it's a function of what level of performance you want to get out of the boat. It's, you know, the one thing you want to make sure of is the bracket is strong enough to support the weight of the boat in the corners, and you've got enough material thickness to keep it from flexing. Turn fin flex is going to kill you on a big, heavy boat.
Okay, that makes a lot of sense.
I mean,
I appreciate it. Awesome, thank you.
My theory on turn fins and turn fin brackets, if you can't pick the boat up by it and shake it, it's not strong enough.
Okay. Good theory. I like it.
Well, Mike Hughes and I ran the numbers on corner loads on turn fins, and we ended up coming right in there between 11.5 and 12 G's worth of corner load if you really get a boat screaming. And, you know, easy multiplication, you got a 10-pound boat, you're talking 120 pounds on that turn fin. So build them strong.
And that's where I'm at right now. So the whole power plant and everything. So I want to maximize as what I can on this well built hull. It's not glass and stuff. It's well built. It's just like you said. It needs some strengthening on the turn fin. Of course, and the rudder needs a whole adjusting too. But no, this is an excellent starting few and stuff. So I'm trying to adjust to what kind of power plant I can get to at this point, because like I said, was trying to get turbine marine engine in it, but unfortunately they stopped producing them. Talked to the company, they
were having too many water ingestion problems and destroying them. It was all bad for them as far as the business model goes. The other thing is, you can, if you do put that bend above the water line on a turn fin, it does stiffen up the fin. It won't flex as much, and you can run a little bit thinner material than you otherwise would if you had to run a flat fin.
Okay.
And on that big boat, you definitely want to put some turnbuckle braces on that fin when you get it all together.
Okay, awesome. Thank you.
Anybody else?
Brian, you hear me? This is Bill Brand.
Hey, Bill, how you doing?
Good. Brian, I know that this is a lot on props and everything, but why don't you bring people up to speed a little bit on the what's trying to be done now with the NAMBR rule on FE motors for scale?
Oh, I did mention we've got a rule proposal coming through with the next prop wash. What we've done between the guys in RCU and the guys in District 3, we've gotten rid of the constraints, and there's a long story behind it. I'm not going to make it serious, get too deeply into it, but let's just leave it that there are rule sets that make fantastic club rule sets and are great recipes for success. But some of those constraints aren't really appropriate for a national organization, for record trials and nationals and that type of thing. Basically, the new proposal coming out goes to a dimensional motor limit, a size limit like we've gone to in P Limited. We did keep the KV limit with a good, solid, easy to test method to check motor KV on site. We've got rid of the speed control specifications. We've gotten rid of the battery limitations that, other than 8S. We kept the 57 millimeter propeller rule. We're keeping all the good stuff in it and opening up the motors to what's available and not having to fight with a motor list every time something goes out of production and we've got to find a replacement. We can just work our way through it, make sure it fits within the dimensional limits and has a appropriate KV, and off to the races.
Sounds good to me. I vote yes.
Thank you, Jim. And we are keeping 8S. I know there was a lot of discontent about that originally, but the boats perform great. We don't need 75 mile an hour 8 scales. When you get to that kind of speed, the boats just don't survive over the long run. They get beat up too fast. Accidents are way more severe. And I'll admit, I'm getting older too. I'm not as fast as I used to be. What else we got out there?
Flex shaft or solid shaft?
For what class?
For 10th scale, modern, and vintage.
Flex cable is probably the most consistent and reliable. It's the easiest to maintain, properly set up. They don't have much drag. If you go to a good oil versus grease, they really don't have a whole lot of drag. That being said, a wire drive, say going to an 078 wire drive, is less drag. The drawback to a wire is you can't run it in a completely straight, well, a thin wire you can't run in a completely straight stuffing tube without having it whip. If you wanted to go to a straight shaft in a vintage boat, go directly to 1/8 inch wire and call it good. But if you're putting a bend in it and you get everything right, a thin wire drive is, you know, an 0.62 or an 0.78 wire drive at the power levels we run in 10th scale is a perfectly viable option. The downside to the wire is if your motor and shaft alignment isn't perfect, it fatigues the wire at the end of the collet, and it will snap. If it isn't perfect, you'll go through 1 or 2 of them a day. If you get it perfect, you'll go years between breaking one. But it has to be just right.
Yeah. Thank you.
Mm-hmm. A backup to that is my straight line boats use cables. So the 4-cell record is held with a 150 cable.
Okay.
We have time for about 1 or 2 more questions if anyone has that, and then we'll pause and we'll have about a half hour after the event's over if people want to hang out and talk more as well.
Mm-hmm.
Hey, Brian, for the ESU, we're trying to run stock props. Right now we have some CNCs that we okayed through RC Boat Bits or something like that, and through Bill Brandt, we're trying to get up something else for 57 right turn or right or reverse props.
Yep.
If we wanted as a club, and we could talk later too, but we want to run stock, so is it what you would suggest would maybe order like 15 of them where we grab them out of a hat before each race?
We've done that before. It works pretty well. Where were we? We were doing that with the SV27 boats 10 years ago, and it actually made for pretty even racing. And I prepped all those. I prepped a dozen props for Eugene, the Eugene Club to run, and it was pull them out of a hat, and it made for really good racing. Yeah. There's lots of right-hand blades available. I mean, there's a ton of right-hand blades available from ABC now. You can thank the European Twin Cat guys for that. They got Jim building counter-rotating sets of a huge portion of the line at this point. So if you want to go to a metal prop, we can find something that works for your guys' boats and go from there. Yeah.
That's good. Yeah, because we want to run. So far, we were not allowed to amend props out of the packages. So based on what you're discussing or stated, it'd be nice to have at least, you know, rather than just a stock CNC prop that you cannot sharpen. I just want to see, so we can't even sharpen blades. Because we want to keep it as even as stock as we can. So maybe that's an option.
I remember the advent of that rule, and I may have been involved in it. I may have been
exactly. I understand both sides, but it's like for our club, we want, because if you know props, you're going to win every race. 90% of us don't know that, so we're trying to make it as even as possible.
So let me pose this question: do you want a production prop that is sharpened and balanced and heat treated that is consistent? I mean, we can get you props built that are very, very good and will perform well, and I can guarantee they'll be consistent. I just did 30 of the same blank for somebody.
Yeah, something similar to that. And again, I'll call you after this or over the weekend or something, because that's
absolutely.
We're going to have a Zoom meeting for ESU here within a week, so we just want to propose that, because it's like, number one, if they don't make them or they run out of stock, what do you do? So if we had a bunch that the club owned, we could just keep racing. Everybody has the same prop, and they've been sharpened. Yeah.
We had been using the plastic, the Bropner props.
The K57s, right?
Right.
Yes.
Just right out of the bag, and they were all the same.
But they broke. So that's why we went to
They
CNC and can't change those out of RC Boat Bits out of Australia. And he has some, but it's like, okay, we can do that. But like you were mentioning, they're not that sharp.
They're not that sharp. And, you know, the CNCs, are they the aluminum props? Or are they the chrome cobalt?
I think they're
Aluminum. They're aluminum.
Yeah,
Okay.
or for the English, aluminium.
Yes, you'll find with time that those propellers fatigue and you'll start losing blades. That was the reason Andy Brown quit building CNC aluminum props 10 years ago.
Okay. Well, we can have the discussion. If you could, we can get your opinion as what you suggest for the 7 scale, and then we can go from there and we'll figure out something. We just have to make sure once we do that, that the club's okay to amend the rules so we can run that prop. Whatever.
Yep, contact me offline. We'll take care of it. We'll figure. I'll be more than happy to help.
Appreciate it. Awesome.
All right. Well, excellent. I just want to, Bill Brandt still has his hand up. I want to make sure that he had his question answered earlier.
He answered it. We're done.
Okay, of course, just want to make sure that you had your questions answered.
Yeah.
All right.
Thank
Well,
you.
thank you so much, Brian, for talking to us.
I can mention though on props, people wanted a bunch of the 4814 CNC props, 3 blades. I think a 351. I do have those in stock, and I still have a fair number if there's any interest. If not, I'll probably stop carrying them. But sold quite a few, and I have quite a few left. So
Excellent. Well, maybe Bill, you can put a link in the chat and for everyone to see that, so you know where to go for that. All right.
Yeah,
so,
maybe I'll try to figure that out. I'll do that now.
okay. All right.
Well, I hope the information's been helpful, and I mean, I'm around all the time. Questions, send them to me. More than
Excellent. Well, again, thank you, Brian, for sharing
Thank
and
you,
talking on that. I think that was a really good talk and just very informational for us. So excellent.
Alrighty, guys.
You know what? The voting has closed. The polls have closed, and I want to announce who the winners are. We have 4 winners. They're getting $25 gift certificates to Hydroplane and Raceboat Museum. And without further ado, here we go. So for work in progress, the winner was actually Bob Brackett. Unfortunately, I don't think Bob was on today, but he won with 32% of the votes for his work in progress for his Graham Trucking, his newest edition. I'm not sure what year that is. Probably.
It's a 0405, David.
There we go. 0405. It's still.
And I only know that because I did his graphics.
There we go. So, right. How you doing, Mike? Welcome.
How are you?
Yeah. And then in second place, the runner-up is Kurt White with his Merc Cruiser. He got 20% of the votes. I think that's he said it's a handful and he's got a lot of more work to do to it. So Bob and Kurt, I'll be getting in touch with you after the meeting to make sure you get your gift certificates. Congratulations.
Cool.
And then we got to say best of
Awesome.
scale for last because that's kind of like the granddaddy of them all. So our winner is actually Nelson Holmberg. And I checked, he didn't cheat. He actually got votes from other people. He got 41% of the votes. So he's getting a gift certificate. And then Mike Crone, and I love that he got it because it's such an oddball boat, and I love oddball boats. The Arcadian. I don't think he's run it yet. He got second place with 14% of the votes. So both of you will be getting gift certificates to the Hydroplane and Raceboat Museum.
Nelson, was it Dominion voting machines?
Yeah.
You're not going to start that, are you?
Yeah. Is Mike gonna spend a month challenging the results?
He might. We'll see. Either way, you both get a $25 gift certificate. So
Thanks, you guys. That's very cool. David, thank you so much.
Yeah, and I love seeing all the photos. So thank you everyone who did contribute their photos to it. And if you have a chance, you didn't get to vote, but still take a look at those photos. There's some great models people are making. I'd love to see them in person. Hopefully next year we can see them in person. But one thing I was actually glad about with this is that we got to see some models from out of local area. People submitted photos from Texas, I think California, Detroit. I got to see my father's first, he built a slow motion 5. I think Jim has that still. He got to submit that. So
This is made, and then this is made on the other side.
Yeah. All right. Well, that's all we have for this year's Roger Newton Memorial. thank you all so much for coming. I really want to thank David Williams for all his help and speaking with us today. Nelson Holmberg for speaking with us and his help in making this happen. Thank you so much, Brian Boas, for speaking, being our keynote speaker, and giving us this wealth of knowledge on props and sharp leading edges on everything that goes on to hardware-wise for our models. And I really appreciate everyone showing up today and being a part of this. That's all we have for our program, but if you want to hang out, we'll leave this Zoom call open until 2, and you can hang out, hang back, and we can talk about whatever you want. So thank you all for coming.
Thank you,
Thank you, David.
Thank you, David. Thanks.
Thanks for having it, David.
Thanks, Nelson.
Thanks for having us.